Ladies and gentlemen, hi. Hi. Yep. Basil, would you mention North Lake? Okay. Amplitude. Amplitude is an absolute value. Do you guys remember what absolute values were? They have no, like it's a distance away from zero. They have no direction. So the absolute value of -3 is just 3. So all I'm saying is that there's no negative or positive. Well, they're all just positive. All right, so the amplitude, like I said, is an absolute value. We don't measure it to be like a depth or a height. We just treat it as a value. The amplitude is the distance between the median value, which we'll talk about soon, and the maximum height. Or you could do it from the median to the minimum, but then you'd have to know that you're not going to use like it as a negative depth. You'd just be referring to it as 2, not -2. It's the height of the wave, okay? For those of you in physics, you've seen amplitude before. Okay, so the period is I want to say the amount of time, but that's not correct. It is the period. Okay, so this deals with range. Amplitude deals with range, and period deals with domain. So we're looking for over the domain, the amount of the domain, let's say that. So this would be something like a maximum to a max, a min to another min, that's a period. Or if you do medians, you have 3 of them, a median to a median to a median. So you can have a max to a max, a min to a min, or 3 median measurements. You guys are like, lady, I don't know what you're talking about, and I promise this will get easier as we actually graph it. And we'll talk about some features of the graph as we go along. So when we talk about period, we're talking about our domain. We're talking about amplitude. We're talking about our range of the graph. Okay, this is exciting. So what we're going to do is we're going to take the unit circle and we're going to actually put it onto a graph. Yeah, that's what we're going to do today. So that's why you need your unit circle close. You need your unit circle close to you. All right, and you guys know what this means, right? We're going to go from -2 pi to +2 pi. So our domain is going to go -2 pi to +2 pi. Will it go to infinity? No. So will there be arrows on my graph? No. Okay, good. Just as long as we're all on the same page. Okay, I think we better start in the positive direction because I think we're good with that, right? So you're given the angle measurements and we are graphing the sine function. Sorry, I lost it in there. We're graphing the sine. So what are we looking for? We're looking at the y values, right, of the coordinate pairs. Okay. So at 0 pi, what is sine? 0. Good job, everybody. At pi over 2, what is sine? 1. At pi, 0. At 3 pi over 2, negative 1. And at 2 pi, 0. Good job. So proud of you guys. Okay, so now we're going to do it backwards. But it shouldn't be anything scary to you guys. So we start and we're going negative pi. That's just negative 1. So then if we're at negative pi, we're at 0. At negative 3 pi over 2, 1. And then at negative 2 pi, oh, look at us. Do you guys notice the pattern in the chart? You look happy, Danica. You look like you're really enjoying this. I feel like maybe she's not. So did you guys notice the pattern? Right? Okay, so there should be a pattern here because this is going to result in a wave graph. Okay, it's going to result in a sine. We call them sinusoidal. That doesn't mean there's the sine function. Sinusoidal is a word for the oscillating wave. Because, you know, we like to mess with you guys in math. That's what we do. Wavy graphs. Wavy graphs, that's what we're doing. Okay, so notice I haven't given you much to go on here. That's exciting. So all I'm doing on my x-axis is I'm picking the angles that we had. So, and then I'm just cutting them in half because that's better for my non-visual kind of brain. What about my y-axis? What's my maximum y value? 1. What's my minimum y value? Negative 1. Okay, that's exciting. Now we're going to plot some points. I'm going to grab a red one. Okay, so let's start at the most obvious. 0, 0. I'm starting in the middle of the chart. Probably not the best idea, but I'm going to start there anyway. And then I'm going to go to pi over 2. I'm going to be at 1. At pi, I'm going to be back at 0. At 3 pi over 2, I'm going to be at negative 1. And at 2 pi, I'm going to be at 0. Okay, so let's keep going. So at negative pi over 2, I'm at negative 1. At pi, I'm at 0. At negative 3 pi over 2, I'm back to the 1. And then I end there. That's a lot of dots. And so if we connect those dots in the order that we graph them, oh, that was a bad line.
Apologies for the mid-afternoon interruption, but we have a Landon Yanko in the building. Please report to the office. Landon Yanko. Thank you.
Okay, does my graph have arrows? No. Why? Because of the restriction. If I didn't have the restriction, I'd put arrows on it. Does that make sense to everybody? But the restriction is stopping me at that point. Okay, so let's talk about this graph for a second. Let's talk about this graph for a second. I didn't flip the page, I just looked at the other page. Go back. Let's talk about it. The median is the physical middle between the max and the min. So the median has to do with your range. So the median has to do with your range, and it's the physical middle of the graph. So it's the middle point between your maximum and your minimum points. Too bet I couldn't spell midway. Okay, so it's the that pencil's not good to use. The midway between max and min. So let's talk about what's our max. Our maximum, that's the height of the highest point of the graph, the max is going to go to 1. And the minimum? Okay, so where's the middle of that? So you've just found the median, and that is at 0. Okay, that's great. So knowing where the median is, can you guys tell me the amplitude of this graph? So the amplitude is from the median, which you told me was at 0, to the max height. So I have an amplitude equal to 1. Isn't that exciting, everybody? So exciting. Now let's talk about a period. So the period can go from a max to a max, so we can measure it from here to here, that's a period. We can measure it from a min to a min, that's also a period. So here's the thing, ladies and gentlemen, is the same, they will be the same values, but it's the distance traveled. So in this case, I'm actually going to do a median to a median to another median. Because if I do that, so from here, from this median, past that median to that median is also a period. Do you guys know why I'd use my medians? Because median, the periods are on the x-axis. Where does this one start? Where does it go to? 2 pi. So you have a period of 2 pi. Okay, but let's do it off a max to a max now. Because that one's pretty easy. It starts at 0, it goes to 2 pi. Let's do something a little bit more difficult. How far have I traveled if I go from negative 3 pi over 2 to 0? I've traveled 3 pi over 2. And then I've gone another half pi. How far have I traveled? 2 pi. So you can do it off a max to a max, and your period would be 2 pi. Your period here is 2 pi. Anybody want to guess? Also 2 pi. Your period's going to be consistent no matter which way you measure it. Everybody good with that? Okay, awesome. Flip the page. We're going to do cosine now. Yeah, we're going to do them all. We're going to do all 3 of our regulars, and then we're going to do all 3 of the reciprocal graphs. Not today, though. Not today. Okay. Now we're on the cosine graph. Now we're on the cosine graph. So let's start at 0 again. So at 0 radians, what's cosine? 1. Because we're looking at the x's now, right? At pi over 2? 0. At pi? -1. 3 pi over 2? 2 pi? Okay. Without ever knowing anything about the unit circle, could you continue the pattern backwards here? Right? So if I'm at a +1, where am I going next? 0, -1. Hey, look, we're doing our best here. Again, I have that restriction, so I'm going to end at +2 pi and -2 pi. So I'm going to go ahead and I'm going to draw my graph again. And again, my max and min on that graph are 1s and -1s, right? Okay, so we're going to graph this one. So I'm going to start again at the middle of the graph. I'm going to have 0 and 1. And then pi over 2, I'm going to be at 0. At pi, I'm going to be at -1. At 3 pi over 2, I'm back to 0. And at 2 pi, I'm at 1. Going backwards here at negative pi over 2, bless you. Then I'm at -0 and 1. Okay, so now I'm going to connect the dots with a nice smooth curve. Ladies and gentlemen, you should not have points on this graph. It's like a parabola. So they're going to be a nice smooth wave curve. Ah, bless you. Jeez Louise. She's allergic to sinusoidal functions. Okay. I'll give you a second to finish graphing your beautiful W. And if I didn't have a restriction on this, ladies and gentlemen, if I didn't have a restriction, my arrow should not point up because are there values beyond 1? No. Where should my arrow point? Down. Half mark deduction if it didn't point down. Half a mark. Well, this one didn't have any, it shouldn't have any arrows. I'm just saying if there wasn't one, your arrow has to be pointing in the direction where your next point should be going. Okay, let's talk about this graph for a second. What's my max? 1. What's my min? -1. What's my median? Okay, what's my amplitude? 1, right? Because it's the distance from my median to either minimum. This would be a distance of absolute value of -1, but it's an absolute value, so we're going to give it a value of 1. You could do it from here to a max if you preferred. That's the amplitude there. Okay, what else do I need to know? Period. Are you sure it's 2 pi? I would agree with you. My graph looks a little wonky on this side because my increments would look wonky on this side. So I'm going to start at 0 again. So this time I'm going to go from a max to a maximum for my period. Because it's always nice, it starts at 0 and it goes to 2 pi. So my period is 2 pi. Isn't that exciting? Sure. Okay, cosine graphs start at a maximum. Sine graphs start at a median. Oh, they can, and we'll talk about that very soon. But so your regular sine graph, where does it start? Starts at 0, 0, so that's a median. Where does your cosine graph start? At 0, 1, so it starts at a maximum. Guys, this is going to be important because you're going to create equations for these graphs in future lessons. Super fun. Okay, so these are your basic, because we're going to do transformations of them. You're going to create equations for them. It's going to be a good time. Okay, amplitude of the sine graph. 1. Amplitude of the cosine graph. Also 1. Period. 2 pi. Period of the cosine graph. 2 pi. Domain. Not the restricted domain. What would this domain be if there was no restriction on it? No, we're doing domain. Yeah. Because we can keep going around that circle forever, right? Right? We keep doing rotations around that circle for infinity. Have you guys ever seen that written as? Okay, I'm just putting it down there so you know that these two things are the same thing. You need to be able to read it. It might not be what you're comfortable doing, but you need to be able to read it. So x, the domain, are elements of the real numbers. What are real numbers? They're regular. They're regular numbers. They're all of our numbers. They're decimals, they're positives, they're zeros, they're whole numbers, they're fractions, they're repeating, they're not repeating. It's all the numbers. Everything that's included from negative infinity to positive infinity. Those are your real numbers.
Miss Guy.
Yes.
I remember Miss Thompson saying that we would have to read set notation for the provincial exam.
Uh-huh.
Is the exam going to have set notation?
Probably. But you guys read it all the time. You read it all the time here.
I'm getting it every single time.
You'll be fine. You'll be golden. Okay, let's talk about the range. Inclusive? Inclusive, thank you. And that's the same for both those graphs. Let's talk about the zeros of the function, and we're going to state it as a general solution.
Oh God, okay.
Okay, zeros of the function, what are those? Yes, you do. What's the other name? We got x-intercepts, zeros, and there's a third name for them. Roots.
It just came to me. I was like, wow, roots. Yeah.
Roots. Okay, so let's talk about our sine graph. So that's the one on the first page. So this is why we're going to do a general solution for them. Where do we see our very first x-intercept? At 0. Where do we see our next one? Pi. Where do we see our next one? 2 pi. So what's happening what's the distance between every x-intercept? Pi. Good. Okay, good job, everybody. So where are we going to start? So the x-intercepts happen at, where did they start? 0. And what are we going to add to them? Pi. And it's a general solution, so it's going to be k, where k is an element of the integers. K is just how many we have of them. Because we're talking about x-intercepts. I don't think x is what we want to use. We want to stay as far away from x as possible. Anybody know why I use theta instead of x? Look at your equations. What do they have in them? Theta, right? So you want to use the appropriate variable with them. All right, let's do the x-intercepts for the cosine graph as a general solution.
They started pi over 2.
Where's your first one? Pi over 2. Where's your next one? What's the distance between those? Still pi. Still pi. So this one's going to be theta equals, where's my first one? Pi over 2 plus pi k, where k is an element of the integers. Because we're going to add as many pi's as we need to, or take away as many pi's as we need to find those x-intercepts. Okay, good thing, y-intercepts, there's only one. Only one. On the sine graph, where is it? 0. On the cosine graph, 1. Any asymptotes on these graphs? No. Those are the invisible lines on the graph, the boundaries that the function approaches but never touches and can never cross. Like non-permissible values. FYI, this is some foreshadowing of things to come. Pablo, are you getting rowdy over there? Like, you're just done? We talk asymptotes and you're out? It's over? Okay. Okay, so that was too easy. That was too easy. All right? So we're going to go bigger and better. We're going to transform. Okay? So we know in function notation from chapter 1, we know that in function notation from chapter 1, if the A is outside of the brackets, if there's a number outside in front of the F, what does it do? It's the Y. We either have a vertical stretch or compression. What if there is a negative on that A value? Reflection in the x-axis. Okay, good job. All of those transformations they apply to every function that we're going to do. Like, so right now we're doing sinusoidal functions. These are the stuff we learned in chapter 1 is going to apply to all the rest of the units. Okay. All right. So we're going to graph y equals sine x. You guys did the table of values already for y equals sine x. Right here. It's on page 3 of your... Let's write it down on the side just for funsies. Pardon? Yeah. They mean the same thing. They mean the same thing. But this one, we're going to go from, obviously I don't have enough to do negative 2 pi here. So let's do what we got. Let's go from negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Everybody good with that? Okay, at 0, what's sine? 0. At pi over 2? 1. At pi?
0.
At 3 pi, my arm doesn't bend that way. 3 pi over 2? Negative 1. Back to 2 pi? 0. So now if I were to go negative pi, or negative pi over 2, where would I be? I would be at negative 1. And again, you can follow that pattern that's there as well. Okay, so are we ready for this? I love it. We're going to need some more. Okay, if I have 2 pi, and every second increment is pi over 2, what's my next increment? 5 pi over 2. And then my next increment's going to be? Yes, it'll be 6 pi over 2, but we're going to reduce that fraction to 3 pi. And then my next increment is going to be 7 pi over 2. And then my next increment is going to be 4 pi or 8 pi over 2. And then if I were to go one more just for funsies, 9 pi over 2. So it's switching back and forth in the fraction world and whole number world. And if that messes you up, then put this as 6 pi over 2, 8 pi over 2. Like if that messes you up, then just do it in the fractions. Okay, let's graph this. Oh, I didn't do my y-axis. Where am I going? 2, 3, so 1, 2, 3. Oh, that won't work. So 1, 2, negative 1. Oh, I love it. Just roll with me on this one. Just trust me. Can you guys just have some blind faith just for a few moments? You can tell them it's only 1 unit. Yeah. But now we're transforming beyond the unit circle. No, I don't want to.
Oh, because we're going to do, okay.
Oh.
Wait,
I might actually have a chance of getting this, not too terrible. Okay. Okay, so let's talk about this. This arrow can go up because this would continue to a maximum. Where does this arrow go? It also has to go up because would I continue more negative? No, I'd be headed towards a median. Do I have a period graphed on there? I do. How do I know I have a period? I have a min and I have another min. So I know I have a min to a min is a period. A max to a max is a period. So I have two mins on there, so I'm golden. I got a period graphed. Okay, good job, everybody. Okay, so now I want to graph this one. I want to graph that one. So, yeah. So what am I going to do with that 3 out front? I'm going to multiply the y values by a factor of 3.
If you have to multiply the x values by stuff, maybe
Yeah.
yes, okay.
Yeah, yes, it is. It will be awful. I don't know how else to say that, but it will be. Okay. So we're going to multiply y's by 3. Oh, sorry, you can't see that. All right, so this is why I went beyond. This is why I went beyond 1. So what do you anticipate? We're going to have a taller, deeper graph, right? We're going to have a higher max and a lower min. And what else is going to change on our graph? The amplitude. Okay, let's graph this. So this one would turn into -3, 0, +3, 0, -3, and 0. So this one's going to be now here. This is still going to be here. This one's going to be at +3. This one's still going to be at 0. This one's going to be at -3, 0. How do we feel about that? Do you guys need me to slow down?
Yes, please.
Okay. I'm just so excited. Because it's this unit, I would say, is true story, but I don't think I can add those in. I think I'm going to upset people if I do that. I'm getting yelled at because I'm going too fast. Can you guys let me know when I'm allowed to go again? I can go? Okay, still putting points on the graph. Okay.
Don't label points in your graph. No.
No. I don't. Chapter 6 is like what I really enjoy. This one just takes some patience.
What is chapter 6?
Chapter 6 is trig identities. And it has no graphing in it.
Well, what else does it have?
It has pain and suffering. But it's super fun once you get it. Okay. Story of math. Okay, what's happening with this next graph? So y values, we're multiplying them by a half. So what do we anticipate with this graph? It's going to be squishy. It's going to be squishy. So can I do this one without a table of values? I think we can. But you need to follow along so I don't lose you. So at -pi/2, I was at 1, but I need to multiply them by a half. So I'm at -0.5. If I times 0 by a half, where am I?
0.
Still at 0. If I times 1 by a half, 1/2. Still at 0. 1 goes to a half, still 0. We should probably label these. What did I do? Oh, yeah, you're right. Absolutely correct. Sorry. I appreciate you. Except I just wiped out my red line. Let me fix that. There we go. Okay, everything's good now. So this is y equals sine x is my red one. My green one is y equals 3 sine x. My blue one is y equals half sine x. Whew. One more. They're not all over the place. They should be close together. Like they should be. Okay. Yes, it will. Because this max will then become a min. Nope. Because it will have a phase shift. It will have a left-right shift when we're doing the equations for it. It will still continue. Your wave pattern will still continue, but where your maxes and mins happen will affect your equation of your graph.
But how do we know there's a change in the max and min?
Oh, well, because this point is going to transform to negative.
Oh, okay.
Do you see what I mean?
Okay.
Okay, so this is, we're going to take the y values and we are going to multiply by -2. Oh, that's terrible. That says y values multiplied by -2. I picked a pink pen and I don't think it's a good idea. Hey, look, I'm doing my best here. Okay. All right, so we're going back to our original. We're timesing -1 by -2. So now we're at a +2. 0 is going to be still 0. 1 is now going to be -2. 0 is still going to be 0. It used to be a -1. Now it's going to be a +2. Still a 0. Whew. Okay. All right. This one's supposed to go down because I'm at a maximum. And this one's it's at a median, so it would continue to a minimum. Okay, you guys ready? Okay, all right. Don't ruin the fun, Cameron. Don't ruin the fun. It's exciting. I would like to flip back to our original graph. Guys, we've done like 3 things. Okay. Starting at 0, where does this graph start? Sine graphs start at a median. They start at a median. Where do you go from the median? To a maximum. Then where do you go? Median. You need to know the pattern. Okay? So median to a max, to a median, to a min, to a median. That is the pattern of the basic sine graph. Let's look at cosine. Where does cosine start? Max goes to, then goes to, then max. Okay? So sine graphs start at a median and they're headed towards a maximum. Cosine graphs start at a maximum and they head to a median. Okay, that is important. Okay, you can determine the amplitude of a sinusoidal function by taking your maximum value, subtracting your minimum value, and dividing by 2. Nope. So, would you guys agree that, hi, guys, I don't, like, this isn't the time to get lost, right? So, this green graph here, would you guys agree that it has an amplitude of 3? Okay. So, what's the maximum? 3. So, we're going to take 3, and we're going to subtract, what's the minimum? Negative 3.
Wait, so you only do this on the original graph, or?
No, you can pick any graph. I'm picking the green one, which isn't the original. Okay? So A is equal to 3 plus 3 divided by 2. So A is equal to 6 divided by 2. A is equal to 3. So even if you can't see it on the graph, you can calculate it. Yeah. Yeah, that's what I said, yeah. Yeah, absolutely. Okay. This is exciting. Okay. What? Guys, you did all of this in chapter 1.
It's not that hard, it's confusing when you have all the graphs.
Okay. All right. Ladies and gentlemen. Okay, do you guys agree that the period on the basic sine graph and the basic cosine graph is 2 pi? Good. Okay, look at that. We are brilliant people. Okay, good job, everybody. All right. Okay, so we're going to apply our rules. So let's graph our basic cosine graph. Let's graph our basic cosine graph. So what was the table of values for that? So this is x, and this is y. Negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I'm taking part of the table from the past page. So I'm going to start just our basic cosine graph at 0 degrees. What's our cosine? 1. And what do we know cos graphs start at? A maximum. Okay? Pi over 2? 0. Pi? 3 pi over 2? 2 pi? 1. And if I go backwards, where am I at negative pi over 2? 0. Okay, guys, let's graph it. Do you want to spread it out a little more? Maybe by 4s? Would that be better? Okay, so that will eliminate that one from the graph, but that's not a big deal. Okay? So, 1, 2, 3, 4. No, you're right, we can't, because we're going to stretch it horizontally. You're right. False alarm, everybody. Ooh, we can do these ones really big. Ah, thank you, Nicole.
How many units did you put a 1 at?
What? Who? What?
How many units after you put a 1 at?
4.
Okay.
I did 4 of them.
That's
Just because there's no vertical stretch in these ones. So I knew I could give myself some space on the y. Okay, I'm holding. Am I allowed to graph or am I waiting? Okay.
No, you'll lose me.
Okay.
1, 2, 3, 4, 5, that's 5 up.
5?
Yeah, I can.
Are we good? Okay. All right, let's graph that first one. So 0 and 1. Pi over 2 and 0. Pi, -1. Where am I going next? Median, and then to a maximum. So notice where my arrows are pointing. Yeah, sorry, we can now. Okay, so my red graph is y equals cos x. All right. Is everybody good with that? What? I think if I add more stuff to this graph, you guys are going to have a mental breakdown. Okay? So this graph should be okay, hopefully, because it's on your unit circle, you feel confident with it, hopefully, and they're just ones and zeros and negative ones. Okay, when the value comes before the x, what do we multiply by? Right, we multiply by the reciprocal. So x multiply by 1 over 4. Right, because we're doing the reciprocal of them. Go back to chapter 1. We always do. There's no shift, so we don't need brackets. X is never true. But you're right, Danica. If there was like a shift, we would add the brackets in. Oh yeah. Oh yeah. They're coming. They're coming. Because they're the easier ones. Yeah. Yeah. Okay, guys. So here we go. All right. So I might need another table of values here. Because my y values aren't going to change, right? Okay, so negative pi over 2 times by 1/4. Negative pi over 8. No, you're going to be fine, people. You're going to be fine. Okay, 0 times by 1 over 4. Okay, pi over 2 times by 1/4. Okay, it's going to be a squishy graph. I concede to that. Pi times by 1 over 4. Pi over 4. 3 pi over 2 times by 1 over 4. 3 pi over 8. And 2 pi times by pi over 4 is going to be pi over 2. Yeah, you can totally put 2 pi over 4. Okay, are you ready? So it's going to be squishy, everybody. Okay, I just want to point out that what's halfway between pi over 2 and 0? So you guys would agree that this line here is pi over 4. So where is pi over 8? It's halfway in between 0 and pi over 4. Okay, so everybody get a really sharp pencil. And we're going to try to graph this little tiny graph. Okay, So we know that. Okay, so instead of panicking, give it a shot. So this right here is going to be negative pi over 8, right here. Well, because we know halfway is pi over 4, and then halfway again is pi over 8. So this is going to be negative pi over 8, and that one is at 0. And then at 0, we're at 1. And then at positive pi over 8, we're at 0. Do you see how squishy this graph is? Very squishy. So pi over 4, we're at negative 1. And then at 3 pi over 8, so that's right here. That's right there. We're right there. Right there. So not to pi, it's halfway in between pi over 4 and pi over 2.
Why did we make the y value so long?
Because we could.
But now my graph's harder to do.
Okay. Okay, so I'm there. And now at pi over 2.
1.
Okay, so let's graph this.
Nothing. It was always 300.
And that's what we would anticipate, is that we would have a significant compression. We'd have a very squishy graph. Ooh, I have a question. What's the period of this?
Pi over 2.
Pi over 2?
I completely get it. I don't think 2 pi is not.
Okay, look at your graph. Look at your graph. Max to max, look at the little one. So from a max to a max is a period. And how far have we gone there? So my period is pi over 2.
I know the table of values is always this simple, and it's just like pi over 2s and pi.
Yes,
Okay.
and then sometimes no.
Why not? Okay, I'm assuming.
Most times yes, but the odd time no, when you're doing like moon phases or tidal tides and stuff like that.
Not,
Yeah.
Oh my god, I'm gonna start pressing graph. Okay.
Okay, yes, this is.
Look at that.
All right. Can we get one last graph on before we leave today? Okay. Oh, you guys have a quiz tomorrow. Okay. So if we look at this equation, what are we doing to the x values? We're multiplying by the reciprocal, so 2. So we're going back to our original chart here. So at negative pi over 2 times 2, I should be at negative pi. Okay? Well, yeah, because the number is in front of the x, right? Okay, zeros? Still 0, thank goodness. Pi over 2 times 2? Pi. Well, 0 times 2 is 0. Okay, pi times 2? 2 pi. 3 pi over 2 times 2. Hopefully it's 3 pi. Hopefully it's not cross multiplying.
I was cross multiplying.
Okay, 2 pi times 2. 4 pi. So what do you notice everything's going up by this time? Pi. So we're just not going to put that one on. Okay, we good? All right. Okay, this one we anticipate to be very wide. This one's not going to end up on the graph because I don't have negative pi. So I'm going to start at 0 and 1. There I am. And then I'm going to go to pi and 0. And then I'm going to go to 2 pi and negative 1. 3 pi and 0. And 4 pi, I'm back at 1. Are your arrows going in the right directions? Okay, somebody tell me the period of this function.
Sure, okay.
So the period of this function is 4 pi. Okay, so this is how you can math it out. This is how you can math it out. To calculate the period, you take 2 pi, because that's the original period. That's the original period. And you divide it by the b value. Not the reciprocal value, but the b value. It's the one times by the x.
Wait, so if you have cos 1/2 x, you do 1/2?
Yep. So cos 1/2 x. We know the period's 4 pi from the pretty picture, right? But if we do the formula, period is equal to 2 pi divided by 1/2. So period is equal to 2 pi divided by 1/2. Period is equal to 2 pi times 2/1. What's my period? 4 pi. So you can math it out. So if I gave you an equation and said, what's the period? You don't have to graph it. You can math it out to find the period. Word. Jeez Louise.